Hello there, this is Douglas Rumbaugh. In my last video, I alluded to the fact that I started writing my own static site generator, and although it is nowhere near finished, I thought that I would put up perhaps a couple of videos talking about my thoughts on how this is working, what I'm doing, and so on and so forth. For this first video on this series of static site generation, I want to talk about equations. Equations were actually the impetus for this whole thing to begin with, because my goal with this whole process is to remove all of the JavaScript from my website, which ordinarily wouldn't be that difficult, except I have a fairly technical blog covering a lot of computer science and math topics, which means that rendering equations is quite important. And the conventional way that that is currently done is with a JavaScript library called MathJax. I wanted to get away from that. Rather than keeping you in suspense, I'm just going to show you exactly what it is that I'm doing and how it works. And then after that, if you're still interested, you can stick around and I'll talk about why I made the decisions that I did. The way in which I am supporting equations without JavaScript is to process the equation on the back end when I'm generating the site and generate an SVG file, which I then embed into the page itself. Over here is the HTML for this particular blog post, and this is, of course, what it looks like in a web browser after the site has been generated. And let's take a look at this first equation block here. So what I'm doing is I've introduced some new tags, which my site generator recognizes for equations. And inside of these tags, I can write an equation using GROFF equin. Now, I'll get into why I'm using equin later. You could just as easily use LaTeX and do this exact same procedure, but I'm using equin here. So I write the equation in here using equin, and then this is what the rendered equation looks like. This is the script which I am using to convert those equation blocks into actual images. So this is going to simply filter the web page on standard input, identifies when it hits those special equation tags. When it hits the opening tag, it starts buffering the equation. When it hits the closing tag, it passes that buffered equation through a processing pipeline and then emits the image tag instead. The part of it that actually does the work of conversion is this pipeline right here. So the first thing that I'm doing is I'm using GROFF to convert the buffered text into a PostScript file. Once I have that PostScript, I then convert it to an EPS to establish the bounding box on it. I then convert it to a PDF, and I then convert it to an SVG. So this pipeline is much longer than it actually needs to be. The reason why I'm using this particular pipeline and not a shorter one is simply because I wanted this to work on OpenBSD as well. And some of the utilities that allow this to happen in a shorter pipeline aren't in the OpenBSD ports tree at the moment. And so this is the sequence of commands that I found that are available on OpenBSD that accomplishes this task. You can definitely do it with fewer steps. And till I actually publish this site generation framework, there's a good chance this pipeline may change. But the point is, this is what I'm effectively doing, is I'm just using GROFF to render it. In principle, if you wanted to use LaTeX instead, you could do that. You would just have to replace this with a call to maybe PDF LaTeX and use some other pipelining to extract the image. But it should be just as possible to use LaTeX as it would be to use GROFF here. The way that I'm actually passing the equation to be rendered into GROFF is using a HereDoc, which is a convenient way of doing this because what it does is it allows me to not just provide the equation itself, which is here. This variable contains the text of the equation that's being rendered, but it also allows me to add SO directives and things like that for including. Right now, this is strictly for colors, so that I can synchronize the colors of the image with the color scheme of my website. However, I also fully intend to use this eventually to include custom defined macros and things like that for equation formatting too. And that's really all there is to this process. It's not all that complicated. One other thing that's cool about this approach is, and I haven't set this up yet, but I fully intend to, is I'm going to do something very similar for PIC to allow you to define graphics, simple diagrams and things in HTML in the same way and have it rendered through GROFF to create an SVG file with the contents of that diagram. That would be a replacement for something like, say, Mermaid. So that's what I'm doing. Now, of course, the question is, why am I doing it this way? So first and foremost, as I mentioned at the beginning, the whole purpose of this exercise is to try and remove JavaScript, which means that I can't use MathJax. And the next obvious question is, why is MathJax the thing that is used? And the answer for that is actually relatively complicated. Well, perhaps the answer isn't complicated, but the situation itself is complicated. Strictly speaking, there is a way to specify formatted equations in HTML using something called MathML, which is a markup for math, as the name would suggest. Now, MathML is not super well supported historically in web browsers. However, I do believe that most modern web browsers do actually have support for it. I'm referring to, say, Firefox and Chrome, I guess are the two super relevant ones. The problem with MathML, just using MathML directly for me, is that part of the reason why I'm trying to remove JavaScript is to make this website work correctly on very simple browsers. Things like NetSurf, for example, or maybe even like a text-based web browser like Lynx. And the set of web browsers that don't support JavaScript has significant overlap with the set of web browsers that don't support MathML. And while that will mean that I've nominally accomplished my goal of dropping JavaScript support, it will also mean that I have not accomplished the reason for that goal existing, which is to broaden accessibility of my website. That's why I wound up going the SVG route. Worst case scenario, someone can just download the image and look at it in an image viewer if they really need to see the equation and they can't see it in the system that they're currently using for whatever reason. And so that's really the reason why I decided to go the embedded image route. As far as why I'm using Equin to do this as opposed to LaTeX, which is certainly the more conventional one, there's a personal reason and also a somewhat pragmatic reason for doing this. The personal reason is that I happen to like GROFF quite a bit, and I like Equin quite a bit, but I don't have very many opportunities to use it. I'm, of course, an academic, and in terms of academic publishing, academics are generally masochists that are obsessed with LaTeX. And as a result of that, I don't have very many opportunities in my day-to-day life to actually use this. So using it on my website gives me an opportunity to stay fresh with my ability to use Equin and play with it. And that extends, of course, to Pick and other things that I'll probably implement later as well. The other reason, though, why I thought about using Equin is because, as opposed to something like LaTeX, Equin is designed at base. Now, of course, for complicated stuff, it doesn't always work out like this, but at base, Equin is designed in such a way that you specify equations in Equin in a very similar manner to how you would say them out loud. What this means is that the raw Equin source here actually makes relatively decent alt text for the image. It's not perfect, of course, but as a first pass, I just want to automatically stick reasonable alt text on my images for some semblance of accessibility. I can simply drop the raw Equin code that I type here into the alt text of my SVG, and it's significantly more useful than the equivalent LaTeX would have been, particularly for someone, say, using a screen reader. This reads a lot more linearly and doesn't involve a whole bunch of special syntax compared to something like a LaTeX equation would. And so those are the two main reasons why I'm going the Equin route. Like I said, it would be trivial to adjust this pipeline to use LaTeX instead. When I actually release this site generator, odds are good that I'll enable support for both, possibly using some sort of an attribute in the equation tag itself to specify whether or not it should use the GROFF pipeline or the LaTeX pipeline, as I recognize that most people who would even consider this are probably more interested in LaTeX than GROFF. But at the end of the day, this is my generator for me, so I want to use GROFF, I'm going to use GROFF. There is a couple of limitations with this approach right now that I have not yet overcome. I shouldn't say they're limitations with the approach. They're limitations with my implementation of the approach. The first is that currently there's some problems with sizing of the equations consistently. Because this is just an SVG, what I effectively have to do in my style sheet is specify heights and widths, and I just specify a max height, max width sort of thing. The problem is that the SVGs aren't all the same height themselves, and so the max height doesn't scale with the actual height of the SVG, meaning that the more lines there are in the equation, for example, here's a nested fraction, means that the equation gets significantly smaller relative to an equation that only has one line in it like this. I'm thinking about ways to overcome that. Worst case scenario, I might just, as a quick and dirty fix, add an attribute that allows you to specify the degree of fractional nesting in the equation so that I can scale it appropriately that way. Just have a bunch of hard-coded classes for different heights of equations, and that's probably the simplest way to do it. But ideally, some sort of an automated solution would be meaningful, and I think it shouldn't be too hard to do. I just have to think about how best to do it. The other significant limitation with this is that, unlike something like MathJax, I do not have support in this system right now for inline equations. So, for example, here, as you can see, I'm simply just typing the equation like normal and marking it up slightly. For example, here is that equation in HTML, and you can see I'm using the var tag around the variables, which gets it in italics appropriately and also semantically identifies what this is. I'm manually adding non-breaking spaces, and then here I'm just typing things normally. So there's certainly a lot of room for improvement here, but I do think that this actually works relatively well. Even inline equations with MathJax, though, have significant problems I've found. For example, when I test my blog on my phone, what I find is that the inline equation sizing is not particularly attractive relative to the sizing of the text around it anyway. I have to significantly reduce the scale in order for the web page to render properly on an Android device, at least on mine. That even doing it the MathJax way is not optimal anyway. So I think this is a perfectly reasonable approach for now, and it's not that confusing. I may create an equation span so I can tinker with the font a little bit and make it clearer that this is actually inline math. There's a lot of experimentation I have to do with that, but the lack of inline math support is certainly a restriction of this particular approach as well. In principle, I could just use like an inline SVG here, but again, you run into the same sizing problems. I don't know that that would work particularly well. So I'm going to avoid that, at least for the time being. One of the great things about Unix is that it provides you with a very powerful set of tools that you can string together using pipelines and scripts. You don't need anything particularly sophisticated other than some basic scripting to do this. And you can get a perfectly serviceable equation rendering system on the back end done without having to use any JavaScript. It works, as you can see, it works pretty well. And so that's the way in which I'm handling equation support in my new website. This website is, of course, not live yet. I'm nowhere near done. So at least as of the time of releasing this video, if you go to my website right now, you'll still get the old Hugo one. In fact, you can find this particular blog post on there if you're interested to compare what it looks like here versus how it currently looks. I'll admit that it's probably uglier in general on the new site, but my new version of the site is mostly focused at personal edification and accessibility more so than it is making a more attractive website. I'm going to keep tinkering with it to try and improve the appearance of it, but it's not really that important. So let me know what you think about this approach in the comments section. I'd be curious to see what you think about doing it this way versus MathML versus MathJax. And I should point out that really MathJax is just a front end that will automatically convert the equation into MathML or an image or whatever, depending upon the support of the underlying browser. So it's not fundamentally different from those things. However, I'm trying to do everything here on the back end. As always, I hope that you found this video interesting and useful, and I'll see you in the next one. I'll probably release a couple of videos over the next couple of weeks talking about this static site generator and various things that I'm doing with it. So stay tuned for those if you're interested.